Alright, so a thought just dawned on me, okay? Like, it's shocking, guys. So, again, I'm trying to talk about stationary versus motion, okay? So, the hard part about creating a stationary cell will be the insulators which are between both magnets, where the coils are running off, okay, with the antennas. To keep it at 45 degrees and to keep it at 23.4 degrees, Jesus was a carpenter. He needed skills, guys. And skills are what I have. Okay, I used to do that stuff. So naturally, when you put two magnets together that are like, rectangular, they're going to want to like line up perfectly, guys. Okay? And I don't want that. Okay? I need mine to be there or there. Okay? All the time. Okay? One is missing. So there's going to be a 45, 23, 45, 23, let's say 45, 23. Okay, there's going to be a slight imbalance. Now, imagine the work that's going to go into this to make it so that two magnets don't do that. You grab two magnets, put them together, and then think about how to keep them at all times at 45 degrees and at 23.4 degrees. Okay? And you have to insulate them. Okay, you can't short them. You can't have them touching with a conductive material. All right. Now, if all that, there's force there. They want to be like this. There's a force, guys, and you are restricting it from being at equilibrium. That's key. These are key. 1, 2, 3, 4, 5. The V, guys. That's the key, okay? In this equilibrium, state that we're trying to contain, imagine now if less work and effort went in to keep those magnets out of phase, okay? Imagine that. Imagine you had it so that the two magnets could freely rotate and float upon one another, okay? Your fixed one, that'll always be like this, and this one can change to be an infinite amount of degrees. Okay? Because of, let's say, some kind of force that I don't know the physics behind right now. But just imagine, that's where your motion comes in. Okay? And over here, you have 5 of these spinning. Okay? 1, 2, 3, 4, 5. Maybe just 4. Maybe you only have 4 spinning, guys. I think you only have 4 spinning. And this one's stationary. Okay? So you're going to have 2 axes spinning. That's where you're going to get your motion, guys. And 4 of these. The magnets are going to be insulated from one another. You have to think of that now. How are you going to insulate 2 magnets from one another and to be allowed to rotate? I'm guessing some kind of bearing. I'm going to say rotation, you probably need a bearing. Okay? Does that mean there's a magnet there? I don't know, guys. We'll have to experiment and find out if I can find out what way to put a magnet at the middle. Or maybe, oh wow, there you go, guys. If I have a bearing, I'm going to need a ring magnet to go around the bearing, and then the coils are going to go off the magnet that way. Okay, there's my ring magnet. I always thought I needed one in here. So imagine that, okay? And then remember, because your circuitry has all the magnets connected, okay? That means at the end of the terminal, when you take all the wires and you connect them all to one wire, okay, that one wire is going to be sharing a spot here. Okay, on any circuit, on both the 120 and the 220 volt circuit, okay, in my fantastical dreams of grandeur. Okay, so think of it this way. In the creation of the cell, the z-axis right here, these guys, that was the moon. That was a 1. But this way, this was Mercury, Venus. That was a 1, and that was a 1 to make a 1. It took 2 instead of 1. 1, 2, 3. 3 is C. The letter C in Roman numerals is 100. 100 and 120. 220. You're using ring magnets or 2C magnets instead of using 2 square magnets. You'd be using 2C magnets maybe. I don't know. two rings. Motion. I think motion is required. Motion would make sense, but I don't know if the whole thing should move. And I think that if there's motion happening here, whatever's happening on that magnet is amplified. And it's all going back to the same. In the end, they're all going to work together. You're only as strong as your strongest member, and you're only as weak as your weakest link. You have to work together. Find a way to make it work, guys. It's not going to be easy. Talking about just getting along in life in general. Okay? There's an obvious duality here, guys. You know? Didn't really account for that yet. And what do I say? Do you think a positive attracts a negative? Look at this, guys. Creation is only multiplication and addition. Okay? Two likes are attracted. You know this. Two likes are attracted. I'm not talking about the same thing you're thinking about. Okay? Polarities and magnets. There. I have motion. I have a new idea for what kind of... Maybe there don't have to be two here. Maybe this is where your circled X is, you know? Maybe there's not two layers. Maybe there's just the one. Because this angle doesn't matter, remember? We don't have to have a 45 or a 23.4 here. Come on. Maybe this one is literally... Holy crap, guys. I love constructs. Of course my childhood toys are gonna come into play at this key moment. I don't really care for the same, but it'd be nice if they were the same color, guys. Look, guys. Remember? It can be decoded many ways, but you have to decode it many ways in order to get the whole picture. And then, to get the whole picture, you gotta put all the different ways you decoded it in the same picture. Maybe that's what's going on, guys. I'm just, you know, X-Men and Cerebro and Cellular Earth, guys. Cerebro, he's in a giant sphere, which is projected onto the walls of the sphere. We live in Earth, guys. You know, X's and O's, guys. You know, hugs and kisses. Holy shit, guys. So maybe you have 4 of these. Okay? And this apparatus rotates. Maybe there's no... Maybe this is completely different. I don't know, guys. Maybe it's connected with coils. Yes, there. Fine. Some kind of magnet connection, some kind of ability to twirl, and you can have antennas and coils and magnets, and I don't know, guys. Magnets and antenna. That would have to be your magnet. Look, if this is your magnet and these are your antennas, I think this would be your antenna, and then you'd have magnet or something, and like antennas going between them, or like, yeah. And 2 magnets touching an insulator, but because of whatever force it's happening, it's causing this whole thing to spin on the other magnet. You know what I'm saying, guys? To rotate on an axis in 2 planes, guys. To make an X, to times it by 10. To times 120 volts by 10. Or, I don't know, guys. Maybe. Okay? Stationary. All we need is this point here. Right here. This terminal. This terminal will connect with both circuits. Okay? Whatever's going on here, you don't have to measure at every spot continuously. You let that be free. But the effects of all what's going on this side, they're all going to be shared at this point, the commonality. I believe. Okay, I'm not sure the configuration yet, but if that's an antenna, that'll have to be a magnet. That means that's an antenna. Okay? And if that's an antenna, then that has to be a magnet. It makes sense, guys. 4 magnets, antenna, bearing, a bearing, there you go. What am I talking about? Bearing, magnet, coils, maybe. I don't know. Bearing, maybe. Maybe just magnet on magnet. I don't know. Insulated. That'd be free to move. Wouldn't go anywhere. Want to stay together, right? You want to stay together, but you just have one swiveling. Okay? Contained in a box. Two circuits coming out of it. Two plugs. Two different plugs that you can plug anything and everything into. Extend off of that. Imagine that, guys. Imagine if this perpetual motion, frictionless motion, or whatever friction is being negated by whatever you're gaining from it, your gain, guys. The gain, it's an amplifier in optical systems. You need an amplifier to increase the gain. The amount of gain you get from your signal, guys. Your signal to noise ratio. Your loss. Anyways. Thanks for listening. Cheers.